Lesson 5.6, Number Patterns. We can make and describe patterns of numbers by finding and using a rule to follow. We look at the given information and rule to create a pattern. The rule says add 5, and it's telling us that the first term of our pattern is a 3. So we start with a 3 and we add 5 to it. That makes us an 8. We add 5 to the 8, we get 13. We add 5 to the 13, we get 18. We add 5 to the 18, and we get 23. We've made a pattern. We can also find a rule by looking for a pattern from the given numbers. And the numbers we're given are 2, 4, 6, 8, and then there's an unknown number. And the numbers are increasing by 2 more. The missing number must be 2 more than 8. It must be 10. We saw that each number was increasing by 2 more. When we got to the 8, we added 2 more. And the rule of a pattern may have more than one operation. Here we've got the numbers 1, 6, 4, 9, 7, 12, 10, and then we've got 2 missing numbers. Well, this rule is plus 5, then minus 2. So what are the missing numbers? We start with a 1. 1 plus 5 is 6. Then we do the minus 2. 6 minus 2 is 4. Then we do plus 5 again. 4 plus 5 is 9. Then we subtract 2 again. That brings us to 7. Then we plus 5 again. Now we're at 12. We subtract 2. We're at 10. And we have 10. We need to plus 5. That's going to give us 15. The second operation for the rule is to subtract 2. So 15 minus 2 is 13. There were 2 operations in the rule. So this was the first operation. Then we did the second operation. See? Then we did the first operation, then the second operation. First operation, second operation. Each number or object in the pattern is called a term. So what is the missing term? This one has the missing term in the center. Can you figure out what the missing term is? Can you figure out the difference between the numbers and what the rule must be? If you said the missing term is 30, you're right. This rule is plus 10. It's skip counting by tens. Now look at these colorful shapes. They're making a pattern. Can you tell what comes next? We have triangle, rhombus, rhombus, square. Triangle, rhombus, rhombus. What do you think comes next? If you said square, you're right. The pattern is triangle, rhombus, rhombus, square, triangle, rhombus, rhombus, square. Here we have a 100 chart. It goes from 1 to 100, and it's telling us to color every third square. So we start with the third square, and we're going to color every third square. So the next square is going to be 6, then 9. So we're going to finish coloring every third square for the entire 100 chart. The next number will be, we're at 9, we go 1, 2, 3, it'll be the 12. And I'm going to finish coloring every third square on the entire 100 chart. Now, every third square is green on our 100 chart. So how many squares did we color? Well, we can count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. We colored 33 squares green. Did you know that we could have looked at this 99 and thought, well, we colored every third square, 99 divided by 3 is 33. And we could have found it that way. So aside from the pattern every third square, what other pattern did we make on this grid? Look at this grid. Look how they're all going in a diagonal here. See that? That's kind of cool, isn't it, that they're all going on a diagonal? We can also look at the pattern that's happening in the ones place. We have 3 ones, 6, 9, and in the ones place we have a 2, 5, 8, then a 1, 4, 7, 0. So it's in the ones place, it's going 3, 6, 9, 2, 5, 8, 1, 4, 7, 0. Then at the 30, it repeats 3, 6, 9 in the ones place, 2, 5, 8, 1, 4, 7, 0, and then it does it again in the ones place. So that's another pattern. This rule says skip count by 3, and our first term is a 3. So we start with 3 and we skip count by 3. We have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. Those are the multiples of 3. Those are the products of the basic 3 facts. So what pattern is happening in the tens place for the first 12 multiples of 3? Well, there's 0 tens here, there's 0 tens here, and there's 0 tens here. There's 1 10, 1 10, 1 10, 2 tens, 2 tens, 2 tens, 3 tens, 3 tens, 3 tens. Do you see that? For the first 12 multiples of 3, we have a 0 tens, 0 0, and the tens are 1 1 1, 2 2 2, 3 3 3. And what pattern is happening with even and odd numbers? 3 is an odd number. 6 is an even number. 9 is an odd number. 12 is an even number. We're going odd, even, odd, even, odd, even. So what's happening with the even and odd numbers in the pattern is they're going back and forth between odd and even. The numbers in the pattern are odd, then even, and it repeats. We can look at the given terms of a pattern to find the rule that was used. We need to use at least 3 terms if there is one operation in the rule. So look at these numbers. It goes from 2 to 9 to 16, and we need to find this missing number. We need to figure out the rule they're using. We also need to write in the first term. Well, we can see the first term is a 2, so we know that one. So to find the rule, we look at the 2 and the 9, and we ask ourselves, what happened to the 2 for the next term to be a 9? Well, it went up, so that's addition or multiplication, right? The difference between 2 and 9 is a 7. If we do 2 plus 7, we get a 9. And then what happened to the 9 for the next term to be a 16? We think, well, this was a 7. 9 plus 7 is 16. The common difference between these terms is 7. The rule must be plus 7. Now we can use the rule add 7 to find the next number. 16 plus 7 is 23. We found what the common difference was between the terms, which helped us find the rule. Then we used that rule to find the missing number. So when the rule has one operation, we need at least 3 terms to help us determine what the missing number is that comes next. We need to use 5 terms if there are 2 operations in the rule to test a pattern 3 times. Here we have the numbers 1, 4, 3, 6, 5. We need to find the missing number. We also need to figure out the rule, and this is going to be 2 operations. We also need to find the first term. Well, that's easy. We can see the first term is a 1, so we know that. So we ask ourselves, what happened to the 1 for the next term to be a 4? Well, it went up, so that's probably addition. 1 plus 3 is a 4. That was a plus 3. What happened to the 4 for the next term to be a 3? So that went plus 3, then it went minus 1. Then what happened to the 3 for the next term to be a 6? Well, that's another plus 3. Then what happened to the 6 for the next term to be a 5? Well, that would be another minus 1, wouldn't it? Now we can see a pattern of the operations. It's a plus 3, minus 1, plus 3, minus 1. So our rule is to add 3, then subtract 1. Now we can use the rule to find the next number. We subtracted 1, so now we're at 5. We must need to add 3. Our next number would be 8. When trying to discover what a pattern is, sometimes just writing a little note to yourself what's happening can help you figure out the pattern. And sometimes it might be multiplication or division or subtraction. There might be 2 operations. And by writing little notes to yourself in between the numbers, it'll help you figure out what the pattern is and what the rule is. So again, we need to find what the rule is and what is the first term. So we can look at these numbers and see 96 is the first term, so we know that. And we start with the 96 and then look at the 84, and we ask ourselves, what is the common difference between these terms? What happened with 96 for it to become an 84? Then what happened to the 84 to make it become a 72? Then what happened to the 72 to make it become a 60, and so on. And if it looks very difficult and we can't find the common difference of the terms moving towards the right, we can see how they change at the end moving to the left. It went from 0 to 12 to 24 to 36. These are going up by 12. But be careful, because going backwards in the pattern, the operation for the rule will be the inverse. If going backwards we're adding 12, then that means going forwards to the right, they must be subtracting 12. 96 minus 12 is 84, and we test our rule minus 12 for each term. 84 minus 12 is 72. 72 minus 12 is 60. And we continue on down and see that minus 12 fits for every term. So we know the rule is minus 12. And going towards the right to look for a pattern and going towards the left to look for a pattern would be very helpful if one of the middle terms is missing. For this one, it says the rule is multiply by 4, then divide by 2, and that our first term is a 2. So here's our first term, 2. We need to multiply by 4, so we use that first term 2 to begin our pattern. We multiply this first term by the 4, the first part of the rule, to find the second term. And 2 times 4 is 8. Now, we have an 8. We divide this second term by 2. That's the second part of the rule, to find the third term. 8 divided by 2 is 4. When we have 2 operations in the rule, we'll create 2 new terms. We multiplied by 4 and divided by 2. That gave us 2 new terms. Now we have 4. We need to multiply by 4. That's equal to 16. We go to the second part of the rule, divide by 2. 16 divided by 2 is 8. That term is 8. We go back to the first part of the rule, multiply by 4. 8 times 4 would be this term. That's 32. Now we're at 32. We divide it by 2. 32 divided by 2 is 16. That's our last term. The rule had 2 operations, so it created 2 new terms. That's the second term, that's the third term. See? Sophia makes 10 bracelets each day, then sells 7 each day. How many unsold bracelets will Sophia have after 5 days? So if she's making 10 and selling 7, the rule is plus 10, then minus 7 for each day. And for 5 days, we would do the plus 10 minus 7, that's 1 day, plus 10 minus 7, that's the second day, and we would do it for 5 days. So if she starts making 10 bracelets the first day, we put a 10 as the first term. Then she sells 7, so now she's got 3 at the end of the first day. We could also start our pattern with just the 3, because that's what she's got at the end of the first day. Now she makes 10 more, so 3 plus 10 is 13. So on the second day, she's got 13. She sells 7 of these, so now she's got 6. And we can write our pattern as at the end of the first day, she had 3. At the end of the second day, she had 6. She makes 10 more. Now she's got 16. She sells 7 of them. Now she's only got 9. And we can write 9 as our third term, as how many she has unsold at the end of the third day. She makes 10 more. Now she's got 19. She sells 7 of the 19. Now she has 12 unsold ones left. And we could just write 12 as our fourth term, as how many she's got at the end of 4 days. She makes 10 more the next morning. That's 22 now, 12 plus 10. And she sells 7 of these 22. That's only 15 left unsold. And we could write a 15 for the unsold bracelets at the end of the pattern. So we know Sophia has 15 unsold bracelets after 5 days. Now, we could also find the difference between 10 and 7 and just multiply it by 5 days. The difference between 10 and 7 is a 3. And 3 times 5 days would be 15 unsold bracelets. She had 3 unsold every day for 5 days. That's 15 unsold bracelets. Bob wants to save money to buy his mother a birthday present, and he started with $3. Every week, he earns $12 mowing his neighbor's yard. Of that $12, he spends $4 and saves the rest. So what is the rule he can use to keep track of his savings each week? So we think, Bob earns $12 but spends $4 each week. So how much is he really saving each week? 12 minus 4 is 8. So he's saving $8 each week. So the rule for his savings is plus $8 each week. And using the rule, what are the next 6 terms of the pattern for the money he has saved? Well, it says he started with $3, so that's our first term. If he saved $8 for this one, we would have 3 plus 8, that's $11. Can you figure out what the rest of the missing terms are? Try to figure them out, and then I'll write them in. Are these the terms of the pattern that you got? 3 plus 8 is 11. 11 plus 8 is 19. 19 plus 8 is 27. 27 plus 8 is 35. 35 plus 8 is 43. And 43 plus 8 is $51. And remember, because this is a problem about money, we have to remember to have dollar signs. So after 6 weeks, how much money can Bob spend on his mother's present? He started with $3. Then we have 1, 2, 3, 4, 5, 6 weeks. He's got $51. We find the common difference. Here it was $8, and that is our rule. We needed to add $8 each week. That's the end of Chapter 5. We're going to move on to Chapter 6, and we're going to talk about equivalent fractions. Those are fractions that are equal to each other. I hope you enjoy the rest of your day, and I'll see you next time. Bye.